This is section 7.3, working with two rates of change. So we're going to be working with two derivatives at a time. So all these little scenarios are going to have two different derivatives. And here's the first example. You do have to copy the essence of the problem. Essence being that there's a water tank that initially has 1,200 gallons of water. The time interval is going to be from 0 to 18. And then it's saying that water is being pumped into the tank by this equation. So Wt is the rate of water going in. At the same time, water is being removed from the tank by this derivative, by this rate. So you have basically a derivative of water going into the tank, and this is a derivative of water leaving the tank, water going out of the tank. So for part A, it's asking, is the amount of water in the tank increasing at t is equal to 15? Why or why not? So they wanted to figure out, is there more water going into the tank at 15 minutes or 15 hours? Or is there more water leaving the tank at 15? So to answer this, you would, for part A, you have to check both the derivatives. So W represents the water going into the tank, and R represents the water leaving the tank. So then you just evaluate each at 15 using your graphing calculators, and the amount of water is going to be decreasing since there's more water leaving the tank than there is entering at 15. So the water level would be decreasing. Now, just as a quick side note, to punch these equations up on your calculator, because it does have sine squared, you have to input them as so. So I've done a screenshot of my graphing calculator, and you notice that you have to put the parentheses around the sign and then square it. Same thing with the other equations. You have to put parentheses around the sine function and then square it to input it in correctly. Alright, so now back to the problem at hand, which says now for part B, to the nearest whole number, how many gallons of water are in the tank when t is equal to 18? So we got to figure out how much water was pumped into the tank by integrating this equation. You also have to figure out how much water was pumped out of the tank by integrating this equation. And then you have to consider also how much water was there at the very beginning to figure out how much there is at t is equal to 18. So take into account how much there is to begin with. Integrate to tell you how much water was put into it, how much water was taken out, and that'll tell you the amount of water that's in. And so for part B, you have to integrate both rates. So adding the initial amount, which is 1200, you integrate 0 to 18. You can do both of these at the same time. You can do Wt minus R of t, integrating this, and you end up with 1,307.79 gallons. And since it asks to round to the nearest whole number, or the nearest whole gallon, it would be 1308 for the amount of gallons in the tank. Alright, moving on to part C, which is the most complicated part, the more difficult part. At what time is the amount of water in the tank at an absolute minimum? And the key word here is it's absolute and it's a minimum. So since you have a rate, you have a derivative of water going in and then the water going out. You're going to associate water going in as positive values, and then associate water going out as negative values. So what that means is when you go to set up your equation, this is going to be a positive, and this over here is going to be a negative, or associated with a negative. So when you go to find your critical points, when you do the analysis, you're going to put W of t minus R of t. So this is the rate going in, taking away the rate going out, and we're going to find the critical points. And so you graph this on your graphing calculator. And just as a side note, how you can graph this on your calculator is by, since you already have y1 stored as your first equation, y2 as your second equation, you can come up with now a third equation that says y1 minus y2, and turn these two graphs off and then just look at the graph of this. And what I'm looking for is the critical points. So here's the graph of W minus R. And what I'm looking for is the critical points. So I found the zeros, which happens to be at 0 at this point, and then at this point. This other one I don't really consider because it's past 18. It's outside of my domain. So I'm just looking for this critical point and this critical point. And so those are my critical points. And since it was asking for an absolute minimum, when I do my analysis, I'm just looking for a negative to positive sign change in W minus R. So I'm looking for this negative to positive sign change. And so this is going to be a possible absolute minimum. And you can kind of look at the graph to see that it goes from negative to positive. That's how it's going to be a possible minimum. But then to figure out which is the absolute minimum, you have to figure out which one of these values produces the least amount. Meaning, this is a possible candidate for a minimum. But now I got to figure out how much water there was in the tank at this critical point. So I kind of have to redo the stuff I did in part B. I have to integrate from 0 to this point and add the initial amount of water, and I end up with 525. So that's the amount of gallons, that's the amount of water that's in the tank at this time. But now I got to figure out, is that the least amount? So now you got to consider how much there was at the beginning, which is at the end point, which is at 0, there was 1200. And then also at the very end at 18, there was 1308, the amount of gallons of water. So I can just use the same answer I got in part B, but I do have to show that I'm considering the endpoints. I'm considering 0, considering 18, and then from these three values, from this one, and this one, the least occurred at 6.495. So that's when the water level is at its minimum. So this is what the complete answer would be, is the amount of water is at a minimum when the time is equal to 6.495, and that's the analysis you would have, the complete analysis to earn all the points if this was a free response question.